Hi guys. Okay, so this is Unit 11, Day 4, our in-class notes, and today we're going to be talking about this term called measure of variability. Your learning target is, I can interpret data to find the interquartile range and mean absolute deviation. This is a brand new idea of the interquartile range that we're going to be talking about. So to begin, measures of variability. A measure of variability is a way of describing how far spread out the data is. It can also be described as how much the data deviates from the center. To deviate means to move away from, like if you're in a car and you deviate, means maybe you're dodging something, you're moving away. So when we're talking about measures of variability, we're talking about how far something is spread out or how far it's moving away from the center. Interquartile range. So now we're right here. The interquartile range, we're also going to call it the IQR, just as short because we like to shorten things. IQR is a measure of variability that splits the data into 4 equal-sized quartiles. 4 equal-sized quartiles. It represents the middle 50% of the data. And it can be found by, so right now this might sound like just a bunch of random words that we're spilling out. I'm going to give you 4 steps on how you can find the interquartile range, and then we'll go ahead and do a practice problem so that way you can try and figure out what we're talking about here. The first thing, number 1, order the data from least to greatest. So on your homework you're going to have some questions and it will say find the interquartile range, and you need to follow these steps in order to do that. So first one, order your data from least to greatest. The second one is find the median, and we did that on our last assignment. And then the third one, and by the way, median, what word does that mean again? Man, I miss having you guys in class because then you could answer these for me. Median means middle. Find that middle number. And then number 3, find the median of the lower and upper quartile. And this is the brand new thing that we'll be practicing today. We'll do an example problem below. And then the last thing, in order to find the interquartile range, you have to subtract 2 numbers. Subtract your higher number and your lower number to find the interquartile range. A small interquartile range means that the data values are close to the median. Okay, so let's go ahead and practice what we've talked about here. Okay, so to begin, the data set below represents the different costs of a camera at a local photography store. I'm reading right here. Write the data from least to greatest, and that's the first step that was up here. Step number 1, order this data from least to greatest. So here we go. If I had to order the prices, I'd say the cheapest camera is $28, and then we have 36, 44, 59, 66, 71, and $108. So what's the minimum price for one of the cameras? It was $28. What is the maximum price of the cameras? It's $108. What is the median price? That means what's that middle price going to be? Let's see, we have 1, 2, 3, 4, 5, 6, 7 numbers here. So I can find the very middle number. One way that I like to do that, and let's go ahead and switch colors here, is to cross off one on each end, a number on each end, and just keep going until you're left with a middle number. Looks like 59 is my middle number. So that means the median price is going to be $59. Okay, so the next step, what's the median of the first half of the data? Well, this is our middle number. So the first half of the data is going to be these 3 numbers right here. And our last half of the data is going to be these 3 numbers right here. So let's see, the median of the first half of the data is going to be the very middle number of the first half. So I'm going to switch colors here. It looks like 36 is our median of the first half of the data. You'll notice right here that it says first quartile. That means our first quartile is going to be $36. Now, what is the median of the second half of the data? And notice that's called our third quartile. So I'll write out here, third quartile Let's go ahead and see which number we're going to get. We just have to find the middle number in our second half of the data, and it looks like 71 is going to be in the middle because we have 66 and we have 108. 71's right in the middle of the last half of the data. So 71 is going to be our third quartile. What is the interquartile range? So let's go ahead and take a look at what we've done so far. First thing, we did order the data from least to greatest. Second, we found what the median is, or the middle number. Then the third thing that we did was we found the median of the lower and the upper quartile. The lower quartile is our first quartile, and the upper quartile was our third quartile. Then the fourth thing is subtract to find the interquartile range. So we need to take our larger quartile, which was 71, and subtract our smaller quartile, which is 36. And what that gives us is the interquartile range. That means the numbers range from 36 to 71. What is our interquartile range? And when I say the numbers range, I'm saying like the median of our quartiles. Okay, so let's do 71 minus 36 and see what we get. 11 minus 6 is 5. 6 minus 3 is 3. So the interquartile range is going to be 35. And I'm going to erase my work right there, so I can write my answer out. And there you have it. That is your IQR, or your interquartile range. All right, let's move on to the next question. The following data set represents the number of cars running the red light at the intersection of Main Street and Avenue A over a period of 2 weeks. Okay, so they gave us some information that we really didn't need to know. What we do need are all of these numbers. Step number 1, let's order the data from least to greatest. I'm going to cross them out as I go because it's really important that I cover all of my steps, because I want to make sure I don't make mistakes. And the easiest way is cross off the numbers you've used, so that way you make as few mistakes as possible. I might even make some mistakes here, but if I'm crossing off my numbers, then I know I can go back and figure out what I did wrong. 10, 11, and 12. Let's see what's next. I have 14 and 2 15s. 18, 19, 20, 21. Okay, first step. Let's go ahead and figure out what our median is going to be. So we can count all of the numbers and just figure out what's left over. I'm going to do that one thing where I cross off the numbers as we go. One on the left and one on the right. And I'm just going to keep doing that, one on the left, one on the right, until it narrows it all the way down. Or you can just count the numbers and divide by 2 and see what's in the middle, right? Well, what if I do one on the left and one on the right, and it comes down to 2 numbers? We have to have a median. It looks like this time there's going to be 2 numbers left over. And if you'll recall from our last lesson, in order to find the median, when there's 2 numbers, you have to take the average of them. So to find the average, we have to add them together and then divide by how many numbers we have that we're adding. And we're adding 2 numbers. So I'm going to add these up, and then I'm going to divide by 2 because we had 2 numbers. And if I do that, I'll get 13. Okay, so our median is going to be 13. Now, to find the interquartile range, this is really important for you to know. We have an even set of numbers. That means our data can be split in exactly 2 halves. Here's our second half, and here's our first half. We need to find the interquartile range. In order to do that, we have to find the first quartile and the third quartile. So let's go ahead and do that. Here we go. I'm just going to cross off on the left and right until it narrows down to one answer. Oh, it looks like we just got 9. So our first quartile is 9. Let's see what we get on the second half of data. And the second half spans from 14 to 21. Left and right, left and right, left and right. It looks like I'm left with 18. Or you could just count in and figure out what the middle number is, right? So to find this interquartile range, I have to take my larger number and subtract the smaller number. Or take my third quartile and subtract my first quartile. It looks like I just got 9. So 9 is my interquartile range. That looks pretty good. Okay, next one. Let's talk about mean absolute deviation. We're going to summarize this as MAD, or MAD, all caps. Okay, the mean absolute deviation measures the spread of the data in relation to the mean, in relation to the average. So we're talking about a spread of data in relation to the average number that you get. It can be found by doing one of these four things. Doing all of these four things. Let's do them in order. Step number 1, calculate the mean of the data set. Calculate the mean. So you have to add up all your numbers and then divide by how many numbers there are. Step number 2, find the difference. And difference means subtraction, remember. Find the difference between each piece of data and the mean. And step number 3, take the absolute value of each deviation. I think you guys are really going to like this part. It'll be like, this is our homework. Awesome. I think most of you will. So, sorry, I should not have written deviation. I was talking when I should have been writing. Find the absolute value of each deviation. Step number 4, sum the deviations. So that means add up the deviations. And then divide by the number of pieces of data. So here we go. Mean absolute deviation close to 0 means that the data values are close to the average. So right now this might just seem like a whole bunch of random stuff. Let's go ahead and do an example problem. Okay, so it says, use your understanding of mean absolute deviation to answer the questions below. Okay, so the question number 3, let me scroll down just a little bit, and I'll be coming back up maybe to look at our steps that we need to do. So it says 7 different students were asked the number of family member in their household. Use the data to complete the table. Okay, so it looks like 7 different families right here were asked to fill out some data. They were all questioned. What is the number of family members that you have? And they all listed out their data. Well, let's go back up to the first step. We need to figure out what our mean is going to be, or the average. And then we have to figure out how much that deviates from the mean. To find the average, we're going to add all of these things up together. Let me scroll back up. Okay, so right here where it says question 1 at the very top, calculate the mean of the data set. Let's add up all of our numbers and then divide by how many numbers we have. Then the second step to find the deviation from the mean is find the difference. That means subtract. So we're going to use subtraction and the mean, whatever we end up getting. Okay, so let's go back to number 3. First step, let's add all of these up. And I'm going to write them out just so you can see exactly what I'm talking about. Let's switch colors here. So in your calculator, I want you to write out or type out 3 plus 2 plus 4 plus 2 plus 5 plus 6 plus 2. Well, if we add all of that up, I'm not sure what I get until I actually add it up myself. 3 plus 2 plus 4 plus 2 plus 5 plus 6 plus 2. Okay, I got 24. Now the next step is we have to divide by how many numbers there are here. And I know that there are 7 different families who gave input. So we have 7 different numbers. Let's divide by 7. So if you were to do 24 divided by 7, that's going to give us our mean, or our average number of family members that each family has. Well, I did 24 divided by 7, and I got 3.42 in this really long decimal. Let's just say 3.4. So our average is 3.4, and we call that rounding to the nearest tenth. Okay, so looking at the deviation from the mean, I told you earlier that we're going to use the word difference. Find the difference, or just use subtraction. I just put a little subtraction sign so you know. So how far away is 3 from our mean? Our mean down here, I'm going to put a big old star by it. Our mean is 3.4. So what do you have to do to go from 3.4 to 3? If we have to subtract, we would get 0.4, right? You take away 0.4 from our mean, and we're going to get 3. Okay? And let me write that up here, how I did that. I did find your average and take away whatever number is listed right here. I'm just subtracting. So that was a difference of 0.4. I subtracted 0.4. All right, now what if I had to do 3.4 minus 2? What would I end up getting? If I did 3.4 minus 2, I'd get 1.4. And in order to get that, I had to subtract. Oh no, that kind of erased all my stuff. Okay, there we go. So, yeah. And so how I'm doing this, sorry, I just had a brain freeze. How I'm doing this is I'm subtracting. So let's go ahead and do the next one. What do you do to go from 3.4 to 4? 3.4 to 4, what am I doing? I'm going to add 0.6. So this is not going to be a subtraction problem, we'll be adding 0.6. So all I'm going to say is the difference is 0.6. To go from 3.4 to 2, right here, I'm going to have to subtract again. I'm going to have to subtract 1.4. What if I went from 3.4 to 5? It looks like I would have to add 1.6. And you can do that by just doing 5 minus 3.4. What about to go from 3.4 to 6? Looks like I'm going to have to add again. So I would have to add 2.6. You could find that answer by doing 6 minus 3.4. Now what do I have to do to go from our average of 3.4 to 2? Again, I would have to subtract 1.4. All right, so I have a bunch of data right here. Now, absolute deviation from the mean. That means, what's the absolute value? Basically, if you were to put all of these in absolute value brackets, let's switch colors again. Let's say that I put this in some absolute value lines like this. What would I end up getting on this side over here? Well, if I had negative 0.4 and I found the absolute value of that, I would just get 0.4, right? Absolute deviation from the mean means that there are no negative numbers. It's just saying how far away is your number, 3, how far away is that number from your average or your mean? Well, it's 0.4 away. How far away is 2 from our average of 3.4? Well, it's 1.4 away. So all of these will just be positive numbers. Okay, that looks pretty good. Now I'm going to erase my absolute value line so I don't mess you up. Okay, so what is the mean absolute deviation? The mean absolute deviation, now we got to go back up to the top to figure out how we find the mean absolute deviation. It says right here, so we calculated the mean, we found the difference, so we just subtracted, we took the absolute value of each deviation. Now step number 4 is sum the deviations and then divide by the number of pieces of data. That basically means find the mean again, because sum means to add. So let's add up all of those deviations, or all of those numbers that we just wrote in this column, and then divide by how many numbers? Well, there's 7 of them. Let's go ahead and scroll down and do that. All right, in my calculator, this is what I'm typing in. Follow along with me if you can. I'm going to add 0.4 plus 1.4 plus 0.6 plus 1.4 plus 1.6 plus 2.6 plus 1.4 equals, and then I have to divide by how many numbers we just added together. Well, we just added 7. So I just did all that. I added it together and divided my answer by 7. And I just barely got 1.3. So the mean absolute deviation is 1.3. And a mean absolute deviation close to 0 means that the data values are close to the average. 1.3 is what we got. All right, so for part B, explain what this means for the size of the families surveyed. Well, this means that the average number of family members was 3.4. So I'm going to put was 3.4. Now I got to scroll down just a little bit. But this also means that most family members from that deviated by 1.3. So I'll just put most family members deviated from that by 1.3. Yeah, I think that's it. And yeah, okay, let's go ahead and move on to our next part of the question number 4. Let me tell you really quickly. As far as this question goes, what this also means, our number of 1.3, what that means is if we took 1.3 and our average number was, or our median, no, our average, our mean was 3.4. If we were to add 1.3 and subtract 1.3 from both of that, from 3.4, that would mean that 2 to 5 members encompass most of the data. So all I did to figure that out was I would say, what's 3.4 minus 1.3? And 3.4 plus 1.3. And that gives us about 2 and about 5. So 2 to 5 members encompass most of the data. Okay, let's go ahead and move on to the last question. Question number 4 says, in a science class, an experiment required counting the number of M&Ms in a small package. Use the data to complete the table. Okay, so let's see. Green M&Ms, it looks like they're counting green M&Ms. They have all of these numbers, 7, 9, 4, 12, 3, 2, 9, 8, 3, and 11. First thing, find the deviation from the mean. Okay, we need to figure out what the mean is going to be. So let's add all of these numbers up and then divide by how many there are. Here's what I'm typing in my calculator. 7 plus 9 plus 4, and I'm just going to add all these up, okay? Plus 12 plus 3 plus 2 plus 9 plus 8 plus 3 plus 11. Okay, I just got 68. Now, I still have to divide by how many numbers there were. So let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There were 10 numbers. So to get the mean, and I'll write this off to this side, I'm going to do 68, because I just added all those numbers up, and divide by how many numbers there are. And there were 10. So 68 divided by 10 gives us 6.8. So that means 6.8 is the mean. Now, how far do all of these numbers deviate from the mean? So to go from 6.8 to 7, so to go from our mean right here, all the way to 7, what am I going to have to add? I'm going to have to add 0.2. What about if I went from 6.8 to 9? What would I have to add? I would have to add 2.2. And I could get that by doing 9 minus 6.8, and it will give me 2.2. What if I went from 6.8 to 4? What would I have to subtract? I would have to subtract 2.8. And if I went from 6.8 to 12, I would have to add 5.2. If I went from 6.8 to 3, I would have to subtract 3.8. If I went from 6.8 to 2, no, we haven't done that one. If I went from 6.8 to 2, I would have to subtract 4.8. If I went from 6.8 to 9, looks like we already did that one, 2.2. From 6.8 to 8, I would have to add 1.2. To go from 6.8 to 3, I would have to subtract 3.8. And to go from 6.8 to 11, I would have to add 4.2. Now, what's the absolute deviation from the mean? So this whole category over here, absolute value means you have those absolute value brackets with your number in between, and whatever you get out, it's going to be a positive number, right? So let's just go ahead and write down all positive numbers right here. 4.8, 2.2, 1.2, 3.8, and 4.2. Okay, so what's the mean absolute deviation? Oops, I just wrote all over the side of that. What's the mean absolute deviation of all of this? Now remember, to find the mean absolute deviation, we found the absolute deviation. That means how far something varies from the mean. But it said to find the mean absolute deviation. So now we have to find the mean. Let's find the average. Let's add all of those numbers up and then divide it by 10 because there's 10 numbers there. So if you're following along with me, here's what I would do. 0.2 plus 2.2 plus 2.8 plus 5.2 plus 3.8. And I got to make sure I'm not making mistakes in my calculator, so I'm double checking this as I type. Plus 4.8 plus 2.2 plus 1.2 plus 3.8 plus 4.2. And I just barely got 30.4. Now the next step was to divide by how many numbers there are in our data set, and we had 10. So I just got 3.04 would be the mean absolute deviation. Okay, so the question is, does the mean absolute deviation represent a large or small amount of variability, and why? Well, okay, so here's what. I would say that that would be a large amount of variability, considering the number of M&Ms in a package. So to vary by 3, like, wow, that 3 looks crazy. To vary by 3, I think that's quite a bit. So I would say that's a large amount. And why? Because we would be considering the number of M&Ms in a package. And I don't think I needed an apostrophe there, but that's okay because I'm a math teacher. Oh no, look what that just did. Number of M&Ms in a package. Okay, so I believe that's it. Let's see if we can keep scrolling. Nope, that's it. So if you have questions, please reach out. We're here to help. And good luck, you guys. You're awesome. Thanks for watching.